Mass production is the absolutely crucial phase in the electric vehicle story that really determines who ultimately gets to own the car. That is precisely why the Model 2 is so very important. Tesla is targeting 2026 to start its large-scale manufacturing efforts. The basic objective is simple to grasp. Build at a consistent speed that successfully lowers the monthly payment, maintains reliable product quality, and dramatically shortens the waiting period from placing an initial order to having the completed car parked in your own driveway. We are going to carefully examine exactly how expanding the factory's capacity translates into real, measurable customer benefits. This includes experiencing fewer delays in critical areas like the paint shop and the wiring installation, using standardized modular components that significantly speed up the final assembly, and implementing a highly efficient thermal system that guarantees the car performs consistently well in both extreme summer heat and intense winter cold. After thoroughly exploring the manufacturing side of things, we will naturally switch our main focus to the car's daily life experience. This specifically means a driving range that is completely sufficient for your entire workweek, so you won't waste valuable time constantly searching out available chargers, offering genuinely quick top-ups when you are driving on the highway, incorporating necessary features ready for cold conditions like snow and road salt, providing driver assistance that actually helps without being constantly irritating or needlessly nagging, and featuring a user interface that you can quickly learn and then essentially completely forget about because it's so incredibly intuitive. If you want coverage on electric vehicles that is always clear, truly practical, and straight to the essential point, please strongly consider subscribing to AutoFusion and help us confidently reach our current target of 10K subscribers. Make absolutely sure to turn on the notification bell so you catch every single update as the Model 2 progresses from being a simple plan to full-scale mass production. The genuine transformation of the Model 2 from just being a mere concept into a car you can actually go out and purchase depends entirely on mass production. This high-volume, large-scale manufacturing process is fundamentally crucial because it is the undeniable deciding factor in whether the Model 2 successfully makes its way into the hands of real, eager buyers. Once the Model 2 smoothly enters high-volume production, the available supply automatically becomes consistent and much more widespread. As a direct result, buyers immediately benefit from having reliable choices for trim options, significantly shorter waiting times, and the complete elimination of the pressure to upgrade to a more expensive version simply because of existing manufacturing shortages. This is precisely the critical point where the Model 2 can move beyond being merely an interesting idea and become a genuine, widely available mainstream vehicle choice. Regarding the factory's consistent rhythm, the Model 2 absolutely requires a consistently stable takt time. This is the fixed, precise interval at which a completely finished Model 2 must roll off the final production line. When this specific takt time for the Model 2 is reliably maintained, bottleneck production stages, particularly in common areas like the painting booth or wiring section, are reliably prevented from severely disrupting the standard scheduled production calendar. At an enormous production scale of several 100,000 vehicles per single factory each year, trimming the takt time by even just a few dozen precious seconds results in a noticeable and meaningful increase in the weekly output of the Model 2. This directly and immediately shortens the Model 2 waiting list and ensures that popular vehicle configurations remain readily and consistently available. Looking closely at the cost factor, higher production volume naturally works to reduce the unit cost of a Model 2 through what is academically known as the experience curve effect. Essentially, the more Model 2 units that are successfully built, the lower the actual cost per unit becomes. Thanks to expensive tools and highly specialized equipment being continuously reused over many vehicles, factory operations becoming much more skilled and practiced over time, and the ability to negotiate much better pricing for components with suppliers. The battery pack represents the single largest cost item in the entire Model 2. If a roughly 50 kWh pack for the Model 2 sees an additional cost reduction of $20 to $30 per kilowatt hour. Compared to earlier production runs, the total component cost for the Model 2 could easily drop by approximately $1,000 to $2,500. Spread out evenly over a typical 60-month loan term, this substantial reduction naturally causes the monthly payment for the Model 2 to decrease by several dozen crucial dollars. As the volume of the Model 2 production steadily climbs higher, subsystems within the car, such as the electric motor, the inverter, the thermal system, and the zonal wiring, continue to be actively optimized. Consequently, the positive trend for the monthly payment improves gradually over an extended period of time, rather than just experiencing a single, one-time reduction. In terms of quality and service, when manufacturing processes are repeated at a consistently high and steady pace, the Model 2 significantly benefits from lower variation during its assembly and a higher overall process capability. Common trouble areas on the Model 2, such as paint finishes, electrical connectors, and thermal lines, are actively standardized by making wiring harnesses shorter, intentionally decreasing the total number of connectors, and performing testing at the specific module level. The direct result of this is a significant reduction in minor issues appearing on the Model 2 and less time that the vehicle needs to spend inconveniently sitting in the service shop. Simultaneously, a stable, high-volume production output allows Tesla to accurately forecast the demand for Model 2 parts across different geographic regions. This means Model 2 owners can more easily book essential service appointments, find required parts already in stock, and frequently complete necessary repairs within a single day. In ultimate summary, mass production for the Model 2 is far more than just a catchy marketing phrase. It represents the steady, completely predictable production rhythm that truly guarantees you receive the exact Model 2 22 configuration you originally ordered. It's the huge scale of production that successfully lowers the Model 2's monthly payment and the stable, consistent manufacturing process that ensures a hassle-free ownership experience with reliable and predictable service. When these three key elements all function together flawlessly, the Model 2 truly becomes an electric car that a very large number of people can realistically afford to buy, finance in a sustainable way, and comfortably use for many reliable years to come. What makes the Model 2 fundamentally ready for mass production deep down, truly under the skin, is a specialized design philosophy entirely centered on high-volume manufacturing right from the initial drawing board phase. It specifically features a low-variation body structure that allows the entire assembly line to operate very stably and brings the final cost per car down to a comfortably low level. The technical choices made aren't just about assembling the car quickly. They are equally and intensely focused on making the Model 2 exceptionally durable and low maintenance for demanding everyday use. The deeper you look into these essential design decisions, the much clearer it becomes how this manufacturing-first approach makes the Model 2 fundamentally different from many previous high-profile electric vehicle showpieces. The Tesla Model 2 begins with a simple, core principle that strongly dictates the success of mass production. The main body structure follows a single, unified blueprint that can successfully accommodate many different trim levels, which actively minimizes the need for unique, specialized stamped parts. By specifically utilizing shared mounting points and panels that are completely symmetrical on the left and right sides, the total number of unique dies required for stamping can be reduced by a significant 20 to 30%. This immediately decreases the necessary time needed for production line changeovers and meaningfully lowers the overall tooling amortization cost spread across each individual car. Fewer body variations also make the complex processes of materials planning and inventory management much more streamlined and inherently efficient. Once this structural foundation is absolutely solid, maintaining a tight takt time of 60 to 75 seconds per car becomes a realistic and achievable target. A production line operating consistently at this swift pace can successfully push out 48 to 60 cars every hour. If that line runs 2 shifts per day, 5 days a week, the total output totals approximately 3,800 to 4,800 cars per week. This level of consistent production is the essential first step for the Model 2 to be shipped steadily, rather than just looking impressive only on paper. However, optimizing the body structure alone won't sustain a high rate of throughput. Therefore, the Model 2 design also specifically addresses the paint shop, which is typically the next major constraint in vehicle manufacturing. The core strategy here is to actively reduce the number of purely decorative paint layers, use colors that are naturally much more weather durable, and apply a factory-installed paint protection film. By intentionally decreasing the time required for spraying and baking, the clear coat process, which happens at high temperatures of 140 to 160 C, stops being a 20 to 30-minute bottleneck for every single vehicle shell. Rework, work needed to fix defects caused by dust particles, small imperfections, nibs, or micro-scratches, can potentially drop from about 3% down to nearly 1%. If a plant is shipping 5,000 cars each week, reducing rework by just 2 percentage points eliminates roughly 100 rework jobs, saving hundreds of labor hours, and most importantly, keeping the Model 2 delivery schedule completely intact. Moving from the fully painted shell to the final assembly area, the wiring harness stage is a very common source of minor electrical faults, when the wiring runs are long and there are numerous connectors. The Model 2 utilizes a zonal architecture that intelligently groups control functions by the specific area of the car and significantly shortens the overall wiring looms. In a typical car, a traditional wiring harness can extend to nearly a kilometer in length and weigh between 40 to 60 kilos. Switching to a zonal architecture commonly cuts this length by 20 to 30%. This saves 8 to 15 kilo of material and eliminates hundreds of connectors that are naturally prone to loosening over time. Every single connector that is successfully removed is one less potential issue for the owner in the first 90 days, largely because the entire electrical network is neater and much more organized. Automated electrical end-of-line checks, performed zone by zone, are also significantly faster and more consistent. As a result, the Model 2 not only assembles quicker, but also achieves a right first-time quality rate at a much higher percentage. With the body, paint, and wiring all made significantly leaner, thermal management becomes the final key piece that determines both the vehicle's energy efficiency and its long-term durability. The Model 2 uses a unified thermal core that manages heat for the battery pack, the drive unit, motor and power electronics, and the cabin interior, all together in one highly efficient system, which drastically reduces the total number of valves and joints required. Instead of more than 20 connection points, which is very common in a split-loop system, the unified design can keep the total down to about 12 to 14 points. This effectively eliminates nearly 30 to 40% of all potential leak paths. The benefits are clearly visible in the car's everyday performance. For instance, during high-speed charging, preconditioning quickly warms the battery cells to their optimal temperature, meaning a typical 10% to 80% charging session can drop from about 30 minutes down to approximately 22 to 25 minutes under ideal conditions. In very cold weather, the shared thermal loop actively prevents performance from significantly dropping, which helps the Model 2 maintain a good charging rate at public stations and remain exceptionally energy efficient even during cold city driving. The battery pack is the precise point where the car's fundamental architecture meets the market need for various trim levels and battery capacities. The Model 2 addresses this essential need with a common pack shell that can successfully house multiple different capacities. Since the external physical structure and mechanics of the pack remain identical, the processes for welding, fastening, leak testing, and initial electrical checks do not need to change at all. The factory simply swaps the internal cell and module cores. A standard 48 to 52 kilowatt-hour version using cost-effective LFP cells will serve the vast majority of the market, while a larger, approximately 60 kilowatt-hour version is readily available for users who specifically need longer driving range. With a benchmark component cost of $100 to $120 per kilowatt-hour for LFP cells, a 10 kilowatt-hour difference in capacity creates only a $1,000 to $1,200 difference in the total component cost. Buyers can confidently choose the standard pack to get a lower monthly payment, while the production line continues to run the exact same process without any interruption. This is precisely how the Model 2 successfully maintains both a high production speed and a useful selection of choices for the discerning customer. To actively avoid an explosion in the parts catalog, the Model 2 standardizes its propulsion hardware and conveniently unlocks power levels entirely through software. The electric motor, the inverter, and the half shafts are designed to be completely identical across all versions of the car. Customers who desire greater performance can simply unlock higher torque or power through a software update whenever they decide they are financially ready to pay for it. The factory benefits immensely by significantly reducing the need for tool changes, achieving a higher first-pass yield rate, and actively shortening the time required for final end-of-line testing. Users also benefit greatly because a later performance upgrade isn't dependent on the availability of rare or specific hardware parts. This way, the production process and the potential post-sale revenue stream become a single, unified system, which keeps the Model 2 line very lean and efficient, while simultaneously allowing the vehicle to remain highly flexible in the competitive market. The final, often overlooked layer of standardization involves the numerous small parts that are frequently missed. Fasteners, clips, and seals are deliberately consolidated down to the absolute necessary set, ensuring that repeated assembly operations are simple, and that the torque control used for tightening is always consistent. A car body can easily use over 200 different types of fasteners if the design is not properly optimized. However, reducing that number to around 70 to 100 types means that robots and human workers swap tools much less often. This simple action alone shrinks the overall cycle times, and significantly lowers the chance of torque errors. Each instance of incorrect torque application can potentially lead to a persistent squeak or rattle after a few thousand miles of driving. The Model 2 successfully mitigates this risk right at the factory, and subsequently, service centers can work much faster because they all use the exact same standard tool set. These seemingly small, deliberate choices directly contribute to the solid, high-quality feel of the car even after many years of heavy use. All of these deliberate steps are logically connected along a clear and logical line. With its modular body and battery architecture, a highly streamlined paint and wiring process, and performance precisely tuned by clever software, the long-term promise is successfully converted into the physical car keys in your hand. If you want to see many more practical, completely no-fluff breakdowns just like this one, please make absolutely sure to subscribe to AutoFusion and turn on notifications so you don't miss any update on the Model 2.